Welcome back. Professor Baldwin here, and today we're going to talk about systems of equations in two variables. Now, a solution to a system of equations would be an ordered pair, x, y, that satisfies both of these equations. Graphically, it's that point of intersection. But there's three different scenarios you could have with a linear system. First is intersecting lines, and see that these intersected at one point, so we have one solution. This system is considered to be consistent because it has a solution, and the equations are independent of each other. The second possibility is when you have parallel lines. Remember that parallel lines never cross, therefore there's no solution. This would be an inconsistent system because there is no solution, and the equations are independent of each other. The third possibility is where the lines are identical. Here, they have every single point in common, which means there are infinitely many solutions. This is a consistent system since there's a solution, and the equations here are dependent equations because they're the exact same line. The first way you can solve a system of linear equations is by substitution. That's where you solve one of the equations for a variable and you substitute it into the other equation. The second possibility is elimination. And elimination is when you add the two equations together to eliminate one of the variables and then solve for the other variable. And then, of course, the third way is graphically. This first example, we're going to use the elimination method, and then we're going to look at an example where we use all three methods. Elimination. So to use elimination, we want to be able to add these two equations together and have one of the variables be eliminated. But notice that we're given decimals. We don't usually like decimals, so our first step is going to be multiplying each of these equations by 10, and that will remove our decimal place. So we multiply each term, and our first equation will become 3x minus 2y equals negative 9. The second becomes 2x minus 3y equals negative 6. These equations look a lot better. Now we want to look at these two equations and figure out which variable will be the easiest for us to eliminate. Either x or y here. I'm going to concentrate on eliminating the y. And to do that, we're going to need to alter these equations. And for y to be eliminated, the common value they would need to have would be 6, right? We can convert negative 2y to a negative 6y, and we can make this second negative 3y a positive 6y. So let's look at how to do that. If we multiply that first equation by 3, we would have 9x minus 6y equals negative 27. Now we want to be able to multiply that second equation and end up with a positive 6y, because doing that will eliminate the y. And what do we need to multiply this equation by to get negative 3y to a positive 6y? Correct. We're going to multiply by negative 2. Now multiply the other two terms. 2x times negative 2 gives us a negative 4x, and this is equal to a plus 12. Now that we've altered the equations, we can use elimination. So we're going to add them together. And we add vertically. So 9x plus a negative 4x gives us 5x. The y's cancel out. They get eliminated. And 5x ends up being equal to negative 15. Now we can divide by 5, and we get x equals negative 3. Now that we have a solution for x, we want to plug it back into one of the original equations. I'm going to pick the first equation. That would give me 0.3 times negative 3 minus 0.2y equals negative 0.9. Let's multiply 0.3 times negative 3, and that's negative 0.9. Our y stays the same. Now we want to slowly isolate the y, so let's add this 0.9 to both sides. And notice we end up with 0.2y equals 0. If we divide by 0.2, negative 0.2, we'll get y equals 0. So our solution for this problem, remember it's a point, it's negative 3, 0. And because we have one point of intersection, we have an answer. So this system is consistent, and we have intersecting lines, which means they are independent of each other. Okay, let's look at an example where we're going to solve with all three methods. So you can see all three methods being used, and you can see that all three methods, if done correctly, will give you the exact same answer. First, let's use graphing. And we're going to use our graphing calculator. But remember to use our graphing calculator, or even if you're graphing by hand, you really want them in y equals format. So starting with the first equation, we have x plus y equals 9. To isolate the y, we need to subtract x. So our first equation becomes y equals 9 minus x. Then our second equation, we have 2x minus 3y equals negative 2. We'll subtract 2x, and we have negative 3y equals negative 2 minus 2x. We need to divide by negative 3. And that gives us y equals 2/3 minus, well, plus 2/3 x, because the minus and the division by the negative. So y equals 2/3 plus 2/3 x. That's perfect. We can enter these into our calculator. So we pull up our calculator. Remember, we want to go into that y equals screen. We'll enter that first equation, which is 9 minus x. We'll enter that second equation, which is 2/3 plus 2/3 x. And then we can hit graph. And notice that those two lines intersect. That's what we want. The intersection is our solution. So we need to use our calculator to find that point of intersection. To do that, we hit second trace, and then we select option 5, which is intersect. Remember, it's asking us, is this your first curve? Double check that your equation's correct. If it is, you can hit enter. Then we're prompted, is this your second curve? Again, check your equation and then hit enter. And then you're asked, do you want to guess? I sure do. And it gives us our point of intersection. X is 5, y is 4. So we'll write that down. This gave us a solution of the point 5, 4. Now let's look at substitution. Substitution is where you solve one equation for a variable and you substitute it into the other equation. I'm going to use this first equation that we solved, y equals 9 minus x, and we're going to substitute it in to our second equation. So, taking our second equation, which is 2x minus 3y equals negative 2, I'm going to substitute this in for y, which will give me 2x minus 3 times 9 minus x equals negative 2. We need to distribute that negative 3, so that's negative 27 plus 3x equals negative 2. Let's combine our like terms on the left. That gives us 5x minus 27 equals negative 2. Add the 27 to both sides, and we get 5x equals 25. We need to divide by 5. And we get x equals 5. Now that we have x, we need to go back to our original equations, pick one of them, substitute it in, and solve for y. I'm going to pick the equation x plus y equals 9 because it's the easiest. I substitute my x, 5, so 5 plus y equals 9. Subtract the 5, and we get y equals 4. So our answer with substitution is the 0.54. That's exactly what we got when we used graphing. I'm going to scroll back up, and now we're going to solve with the elimination method. And with elimination, remember you take those given equations, and the goal is to be able to add them together and eliminate one of the variables. Well, I'm going to change this first equation so that when I add them together, I get rid of an x. So we're going to keep the second equation exactly how it is. And I want my first equation to give me a negative 2x. So I need to multiply everything by negative 2. That would give me negative 2x minus 2y equals negative 18. Now I can add them together. The x's get eliminated. Negative 2y minus 3y gives me negative 5y. Negative 18 minus 2 gives me negative 20. Divide by negative 5, and I get y equals 4. I have my y value. Now I need my x value. Remember, you always go back to one of the original equations. Again, I'm going to pick the easiest. X plus y equals 9. I know that y is 4, so x plus 4 has to be 9. Subtract 4 from both sides, and I get x equals 5. So the elimination method gave me the 0.54. Notice that this 0.54 is what we got with all three methods. So it doesn't matter which method you use, as long as you use it correctly, it's going to get you the proper answer. Sometimes one method will definitely be easier than the other, so don't be afraid to give up on a method and try a different one. Hope this was helpful. If you still have a question or there's a problem that you need some extra help with, leave it in the comments and I'll be happy to make a video for you.